Morning children. So here we will continue with the same exercise questions. First one is convert into moles, and that you have to first convert 12 grams of oxygen gas into moles. Okay, so we will apply the same formula. Direct formula is there. Number of moles is equal to given mass divided by molar mass. Now we know the given mass is 12 grams of oxygen gas. So we will write here 12 grams divided by molar mass of oxygen. First we should calculate. So to calculate molar mass of oxygen gas, first we have to calculate the molecular mass of oxygen gas. Oxygen gas means it is oxygen molecule, because oxygen gas always is in the form of O2, that is in the form of oxygen molecule. So whenever it is written oxygen gas, then you should know that it is talking about oxygen molecule. If it is written oxygen atoms, then we'll just calculate the atomic mass, and if it is written oxygen gas, then we have to calculate the molecular mass of oxygen. So molecular mass of oxygen is equal to, I will calculate 2 into what is the atomic mass of oxygen, 16. So we will get here 32U. So molar mass of oxygen we will get 32 gram. So this we have to put here in the molecular mass. What is there? 32 gram. Okay, so 12 gram by 32 gram, we will get 3 by 8, that is 0.37 moles. Moles we have to calculate, no? So this is the answer. So 12 gram of oxygen gas means 0.37 moles. As I told you before also, if you don't know the formula, you can also go for the unitary method. In unitary method, you have to first show that 1 mole of oxygen gas contains, how many grams? 32 grams. So 32 gram is contained in 1 mole of oxygen gas. So 12 gram of oxygen gas is contained in, that you have to go for the unitary method, and same thing you'll get 0.37 moles only. Okay, so in the homework also I'll give you the questions based on the exercises what we are solving here, and I will expect you people to solve the problem in both the methods, that is in unitary method also, and by just applying using the formula also. Okay, now second one is 20 gram of water, B. So convert into moles. The second question is 20 gram of water. So to convert 20 gram of water into moles, we will just apply the same formula. Number of moles is equal to given mass by molar mass. Okay, so given mass, what is there? 20 gram is given mass of water, and molar mass we have to find out. So first we will calculate the molecular mass of water. Molecular mass of water, that is equal to 2 into atomic mass of hydrogen, that is 1, plus O, atomic mass of oxygen is 16. So we will get 16U, 2U plus 16U, and we will get here 18U. And so we'll just get the molar mass also. Molar mass of H2O automatically will be 18 gram. So this we have to put on molecular mass of water. So it is 18 gram. So 20 gram by 18 gram, you will get the answer. How much? you will get 10 by 9, that is 1.1 moles. Okay, so 20 gram of water means it is 1.1 moles. So like that you can do for C is there, and it is asking here to convert 22 grams of carbon dioxide. So this I'll give you as a homework. You just solve this question in your homework, okay, to convert 22 grams of carbon dioxide into moles. We'll see the other exercise question, that is write the chemical formula of the following. Following compounds are magnesium chloride, copper nitrate, calcium carbonate and calcium hydroxide. Okay, so these are the compound whose chemical formula are to be predicted. Okay, so first is magnesium chloride. As I told you that there is a method to predict the chemical formula, and that is called cis-cross method. You know, by crossing over the valencies of the elements present in the chemical compound, we can predict the correct chemical formula of any chemical compound. Okay, so what are the chemical compounds I have written here? They are all ionic compounds, and you know that cis-cross method are generally applied for the ionic compounds. Okay, and for different compounds only, but here in this lesson we have seen most of the we have predicted the chemical formula of mostly the ionic compounds only, except 2 or 3 compounds which are covalent in nature. Okay, so first we will see magnesium chloride. You know the combining elements in the magnesium chloride are magnesium and chlorine, and you know that before going for the cis-cross method we should have knowledge about the ions and net charge acquired by different ions. Okay, so why? Because this net charge only acts as the valencies for the ions. Okay, magnesium, you know the net charge acquired by magnesium ion is +2. Okay, and net charge acquired by the chloride ion is -1. Okay, we'll write just minus. Okay, and these charges, the net charges on ions, that is magnesium ion and chlorine ion, acts as their valencies. Okay, so we will first write the name of the elements present in magnesium chloride. So elements are magnesium and chlorine. Okay, and what are their valency? So valency we'll just write below their symbols. So magnesium valency will be just 2, we will write, and chloride valency will be 1, because net charge on chloride ion is -1, so valency automatically will be 1. As I told you, valency is the number of net charges acquired by any ion. Okay, so just number we have to write. We should ignore the charges. Valency means number of the net charges acquired by any ions. So how many numbers are there? There are 2 positive charges, so we will just write the number 2 here, and chloride ion have 1 negative charge only, so valency will be just the number 1. Okay, now we will do the cis cross. Here we'll cross over. When we cross over, so magnesium will take the number 1, so we will write here Mg1. Okay, and chlorine will take number 2, because we have done the cis cross now, so Cl2. So the formula we will predict is MgCl2. We will ignore 1 here. Okay, Mg itself shows there is 1 atom, so there is no need to write or no need to show 1 here. Okay, we'll just ignore it. So we have predicted the chemical formula of chemical compound, that is magnesium chloride, which is MgCl2. So like that we will do for the copper nitrate also. So you know that copper shows the variable valency. If you remember, variable valency means it acquires +2 charge also, and it acquires +1 charge also sometimes. Okay, so copper nitrate, if it is asked, so you can just show it can be cupric nitrate, or it can also be written as copper 2 nitrate. Okay, or it may be in the form of cuprous nitrate, or you can write as copper 1 nitrate. Okay, so copper 2 nitrate is also called as cupric nitrate, and copper 1 nitrate, it means it is cuprous nitrate. Why we are writing copper 2, or what do you mean by cupric? As I told you, copper is in the form of Cu2 plus also, and copper sometimes is in the form of Cu plus. Okay, so if it has the net charge on it, that is 2 positive charge, then it is called as copper 2 or cupric. Okay, and if it contains +1 positive charge on it, then it is called as copper 1 or cuprous. Okay, so we will predict the two formulas, that is first cupric 2 formula of cupric 2 nitrate, that is copper 2 nitrate, that is cupric nitrate, or copper 1 nitrate, that is cuprous nitrate. Because here it is in the question, it is not mentioned whether it is copper 1 nitrate or copper 2 nitrate. It is just written copper nitrate. So copper nitrate means it could be in the form of copper 2 nitrate, or it could be in the form of copper 1 nitrate. So we'll just predict first the formula of copper 2 nitrate. You know that copper 2 nitrate means copper acquires +2 charge on it, and nitrate, if you see the formula of nitrate ion, it is in the formula is NO3, and it acquires net 1 negative charge on it. So we can just write copper and NO3, that is nitrate. And if you write the valency, so valency will be, as I told you, in the form of, in the case of ions, the number of net charge only will be its valency. So number of net charge on copper is 2, and number of net charge on nitrate is 1, -1 charge, so 1. We will do cis cross, and copper acquires Cu1 and nitrate acquires NO3. So it will do here bracket, so that it shows that 2 belongs to the whole nitrate group. If you don't put the bracket here, it means it will be confusive. Okay, so we will just write here the bracket, and we have to write here 2 overall. Okay, the whole 2. Okay, so Cu1 NO3 2 can be written as Cu NO3 whole 2. So this is the formula of copper 2 nitrate or cupric nitrate. Similarly, we will do for cuprous nitrate or copper 1 nitrate also. So you know, it is copper 1 nitrate means Cu plus, copper 1 means Cu plus, and NO3 nitrate will be like that, NO3 minus. So here also, if we write Cu and NO3, and its valency of copper will be, copper 1 will be here 1. 1 indicates it is a cuprous, means it has +1 charge on it. Okay, and nitrate also has 1 valency. When we cis cross it, we will get the formula Cu1 NO3 1, which can be written as CuNO3. So this is the chemical formula of copper 1 nitrate or cuprous nitrate. So just for copper nitrate, the formula may be CuNO3 the whole 2 or CuNO3. If it is CuNO3 whole 2, that means it is copper 2 nitrate, and if it's just CuNO3, then it is copper 1 nitrate. Okay, now we will do for the calcium carbonate. The other name of calcium carbonate is also lime stone. Okay, why I am giving you this, that this is the common name of the chemical compound. Okay, now calcium carbonate means it has calcium and carbonate ions present in this compound, ionic compound. So if you see the calcium has 2 plus charge on it. Okay, and carbonate will be written as like this, CO3 2 minus. It has also 2 minus charge on it. Okay, so we'll just write the elements calcium and carbonate, and we'll write the valency, that is 2, and CO3 also has how many number of negative charges? 2. So valency will be numbers, the 2. So okay, we'll just cross this and we'll get Ca2 Ca3 CO3 whole 2. So 2 will just be simplified and we will get CaCO3. So CaCO3 is the chemical formula of calcium carbonate. Okay, don't forget to put the bracket over those ion which is made up of group of atoms, because if you forget to put the bracket here, then whatever the subscript you put here will not belong to the whole atoms, group of atoms, but it will belong to just a single atom. So always put bracket if you have the ion which is made up of group of atoms. Okay, now the next one is calcium hydroxide. Now calcium hydroxide's common name, if you see, then it is called as select lime. Select lime, and it is also called as lime water. Okay, it is also called as lime water and its common name is select lime. Okay, so calcium hydroxide means it has the calcium ion which will have +2 charge on it, and it has hydroxide ion which have 1 negative charge on it. Hydroxide ion will be written like OH minus. Okay, so the elements are calcium and ions are calcium and hydroxides, and valency, if we'll write, valency of calcium will be 2, and hydroxide, in hydroxide we have 1 negative charge, so number will be 1. We'll do 6 cross and we will get Ca1 OH2. So Ca1 OH2, which can be again written as CaOH whole 2. We have ignored 1. Okay, so chemical formula of calcium hydroxide or select lime is CaOH whole 2. So like that you have 2 more compounds which is given in the exercise question. That will be your homework. I'll give you in the homework to do. Okay, we'll see the other question. Give the names of the element in the following compounds. Now what are the compounds? First is quicklime. So you have to write the elements present in quicklime. So first we should know what is quicklime. Quicklime is a common name and the chemical name of quicklime is calcium oxide. So when we will get the chemical name, or we can say IUPAC name of any compound, then we can easily predict the elements present in any chemical compound. Okay, so now you know that quicklime is the common name of calcium oxide. So now you can just predict what are the elements present in calcium oxide. So it is easy if you write the chemical formula of any chemical compound. It will be easy to you then to predict the elements present in the chemical compound by just seeing the chemical formula. So what is the chemical formula of calcium oxide? Chemical formula of calcium oxide is CaO. So what are the elements then? Elements are calcium and oxygen. So you can just write elements are calcium and oxygen. So quicklime, in quicklime the elements present are calcium and oxygen. Okay. Now second is hydrogen bromide. So if you write the chemical formula of hydrogen bromide, it is HBr. So easily you can just predict the elements. Elements are here hydrogen and bromine. Okay, hydrogen and bromine are the elements present in hydrogen bromide. Okay, chemical formula is HBr. Now third one is baking powder. You know we use baking powder at our home, okay, for different purpose. So this is the common name. So from common name we cannot predict the elements present in baking powder. So first we should know the IUPAC name or the chemical name of any material. Okay? So the chemical name of baking powder is sodium hydrogen carbonate. Okay, it can also be called as sodium bicarbonate. Okay, so sodium bicarbonate, you know, if you don't know how to predict, then you can just do crossover as we have discussed before, and you can predict the chemical formula, and from chemical formula you can predict the elements present in them. Okay, so sodium hydrogen carbonate, sodium bicarbonate, you know, it is HCO3 and sodium Na. So sodium, it is called as sodium bicarbonate, HCO3 is called bicarbonate. Okay, or you can say sodium hydrogen carbonate. Okay, so chemical formula of baking powder is NaHCO3. Baking powder is the common name of sodium hydrogen carbonate or the chemical compound sodium bicarbonate. Okay, so easily we can write the elements. Elements are here what? Sodium, hydrogen, carbon and oxygen. So elements are here sodium, hydrogen, carbon and oxygen. Okay, you can also write symbols also. It is good if you write names also, their symbols. Okay, chemical symbols. Now potassium sulfate. Potassium sulfate, name itself indicate the formula potassium sulfate. Okay, K2SO4. If you do crossover, then you can predict the correct chemical formula of any chemical compound. Okay, so K2SO4 is the chemical formula of potassium sulfate. So elements present here are potassium, sulfur and oxygen. Okay, so elements are potassium, you can write like that. Okay, sulfur and oxygen. Okay, like that. So these are the some of the chemical compounds and their elements present in them. Now we will see solved homework questions. First is write the chemical formula of the following compounds and find out the ratio by mass of combining atoms. Okay, for that I gave you one table also, but before just writing directly the ratio by mass, it is better you to show so that I can just see you people how you have done it. So most of you have explained also, you have shown how you have got the ratio by mass. Some of you have just written directly also. Some of you have done the description in the table itself. So that is also okay, but it is better you to show how you have got the ratio. Okay, so I'll just show you how you will get the ratio by mass of the combining atoms of any of different chemical compounds. First I gave you methane. It is not methane, it is methane, M-E-T-H-A-N-E. Just correct your spelling if you have written wrong. Clearly in the question I gave you M-E-T-H-A-N-E, that is methane. So the chemical formula of methane is CH4. Okay. So we have to find out the ratio of combining elements by mass. So what are the combining elements here? They are carbon and hydrogen. Okay. So to get the ratio by mass, we have to write the molecular mass of methane. Molecular mass of methane is atomic mass of carbon, that is 12U, plus 4 into atomic mass of hydrogen, that is 1U. Okay. So we will get here 12U plus 4U. Okay. So that means carbon is in the ratio 12 and hydrogen in the ratio 4. 12 is to 4. We'll just cancel it out, 1 and 3. So simplest value we have got 3 is to 1 here. So methane will be in the ratio 3 is to, in methane, in which combining atoms will be in the ratio 3 is to 1. So they are in the ratio 3 is to 1. Okay. Now we will see calcium carbonate. Formula for calcium carbonate is CaCO3. So we'll just, while writing the molecular mass of CaCO3, we'll write that atomic mass of calcium. Atomic mass of calcium is 40. Now what are the combining atoms here in calcium carbonate? Calcium, carbon and oxygen. So ratio of calcium, carbon and oxygen we have to find out in calcium carbonate. Okay. So atomic mass of calcium is 40 plus atomic mass of carbon is 12 plus atomic mass of 3 into atomic mass of oxygen, it is 16. So we'll get here 40U plus 12U plus 48U. Okay. So if we do the ratio 40 is to 12 is to 48. Okay. So we'll just simplify it by dividing it with 4 to every number. So we'll write here 4 10 ja 40 we got, 4 3 ja 12 we got, and 4 12 ja 48. Okay, we've got here now. So now further can we simplify it by anything? Any number? No. So this is the simplest ratio we have got. So the ratio of combining elements in calcium carbonate is 10 is to 3 is to 12. Okay. So 10 for calcium, 3 for carbon and 12 for oxygen. So anytime if you are thinking to prepare calcium chloride, calcium carbonate, then you have to combine these very atoms, that is calcium carbonate and oxygen, by in this ratio only, that is 10 is to 3 is to 12. That is 10 grams of calcium, 3 grams of carbon and 12 grams of oxygen. Then you will get 1 mole of calcium carbonate. Okay. Now, hydrochloric acid. Hydrochloric acid formula is HCl. Okay, it is also called as hydrogen fluoride also. So, hydrochloric acid. So, we will write here the molecular mass of HCl is equal to atomic mass of hydrogen. It is 1 plus 1U plus atomic mass of chlorine, that is 35.5U. So if we ratio, we will see it will be 1 is to 35.5. Okay, so ratio will be 1 is to 35.5. It is the simplest ratio we have got for the combining atoms, that is hydrogen and chloride in hydrochloric acid. But if you want it to be in whole number, to come in whole number, you can multiply both the things with 2. Okay, if you multiply both the things with 2, you will get 2 is to how much? 71. Okay, so you can write this ratio also, or you can write this ratio also. Both are correct. So the combining elements for the hydrochloric acids will be in the ratio of 1 is to 35.5 or in the ratio 2 is to 71. Okay, so here we can write 1 is to 35.5 or 2 is to 71. Okay, the next one is potassium chloride. So potassium chloride formula is KCl. Okay, and we will write the molecular mass of KCl is equal to atomic mass of potassium. It is 39 U plus, you know, atomic mass of chlorine is 35.5 U. Okay, and we will get 39. So ratio in the form of 39 is to 35.5. So the ratio of potassium chloride will be 39 is to 35.5. Okay, so whenever you are stuck with the chemical formula sometimes, then again you can use the cis-cross method to predict the correct chemical formula, and after writing the chemical formula you can just take out the find out the ratio of the combining atoms by mass. Okay, the next one was, fifth one was zinc oxide. Be careful for the atomic masses. You should mug up all the atomic masses of the atoms or the elements up to 30 atomic number. Okay, so zinc oxide formula is ZnO. Okay, and if you see the molecular formula, it is equal to the molecular formula of zinc. If you are finding out zinc oxide, so atomic mass of zinc, what is the atomic mass of zinc? It is 65.4 plus atomic mass of oxygen, it is 16. Okay, 16 U. So it will be in the form 65.4 U. So it will be in the ratio of 65.4 is to 16. Okay, so like that you can, if you want in whole number also you can simplify it, but it will be in the ratio 65.4 into 16 only. Okay, sixth one is hydrogen peroxide. Okay, if you see the formula of hydrogen peroxide is H2O2. be careful with the chemical formula, also the atomic mass. Some of you have written the atomic number in place of atomic mass, and you have found out the ratio, which is wrong. I told you to correct also. So here if you see the molecular mass of H2O2, that is hydrogen peroxide, 2 into atomic mass of hydrogen, it is 1U, plus 2 into atomic mass of oxygen, that is 16U. You will get 2U plus how much? 32U. Okay, so ratio will be 2:32. But here we can simplify it by dividing it with 2, 16. So you get 1:16 ratio of combining atoms by mass. So here combining atoms in hydrogen peroxides are hydrogen and oxygen, and they will be in the ratio of 1:16. Okay, combining atoms in zinc oxides are zinc and oxygen, and they are in the ratio of 65.4:16. Okay, so after doing all these things, now you can write everything in the form of table that I gave you. So methane, we got the chemical formula CH4. Constituent elements or combining elements are carbon and hydrogen, and ratio by mass we got 3:1. Then calcium carbonate chemical formula is CaCO3, and combining elements are calcium, carbon and oxygen, and they are in the ratio of 10:3:12 by mass. Okay, then hydrogen chloride or hydrochloric acid, it is HCl chemical formula, and combining elements are hydrogen and chlorine, and they are in the ratio of either 1:35.5 or 2:71 in the whole number by mass. Okay, then potassium chloride, KCl is the chemical formula of potassium chloride. Then you have potassium and chlorine are the combining elements, and they are in the ratio of 39:35.5 by mass. Then zinc oxide chemical formula is ZnO, and combining elements are zinc and oxygen, and they are in the ratio 65.4:16 by mass. Then the last one is hydrogen peroxide. The chemical formula of hydrogen peroxide is H2O2. Combining elements are hydrogen and oxygen, as you can see, and the ratio by mass of the combining atoms, that is hydrogen and oxygen, is 1:16 by mass. So like that it is written. Okay, thank you.